So today we are going to start magnetic circuit. Our aim of this studying this magnetic circuit to understand the basic concept which we can apply in different electrical machines. As we know, we are using so many electrical machines. They are based on magnetic circuits. Their working principle based on magnetic circuit. So we have to understand the basics of magnetic circuit to understand the working principle of electrical machine clearly. So here I have shown one example of magnetic circuit. This is an example of magnetic circuit. So magnetic circuit basically consists of a magnetic material which we are naming magnetic core. You can see here we have written magnetic core here, core. This core has certain length. The length is taken as LC. So this is one magnetic material. We have made this type of structure. So for making one magnetic circuit, we need a magnetic material with which we have made a core. Then that core is wounded by a coil or winding. You can see this is the windings. And these are the number of turns. So we can count how many number of turns are there. These are windings having n number of turns. We have denoted number of turns n. So what is the concept of this circuit? When current will flow through this winding, flux will be created in this core. Core means magnetic core. So flux will produced due to this current in this core. It will be circulated throughout this path. So this magnetic path is nothing but your magnetic circuit, you can say. In air also flux will travel. So here you can see we have taken an air gap also. Flux can flow through the air also. Now what is magnetic flux? What is the meaning of magnetic flux? It is the number of magnetic lines of force that come out of North Pole or enter at the South Pole of a magnet. So basically, if I will take a magnet and if I will place, I hope all of you have seen this experiment in your +2 career. If I will take a magnet, if there are North Pole and South Pole, and if I will spray some magnetic dust, it will create like this. The structure will be created like this. So these are nothing but lines of force where we can feel the attraction for magnetic material. So many number of magnetic lines of force will created here. So magnetic flux means magnetic lines of force will be created. Then next thing we have to understand what is the magnetic intensity or magnetizing force. So intensity means you can say how much power we will feel or how much force we will feel in a magnetic area or any magnetic field. So magnetic intensity can be defined as, before that we should study the magnetic flux density. That is defined as flux passing per unit area. Flux passing per unit area. So flux passing per unit area means you can see density. Density will say how densely these lines of force are there. How densely. How many lines of force are there in a particular area? That will be given by this density. Again, I am repeating what we have studied till now. What is a magnetic circuit? Now, if I will take a magnetic core, and one winding is there, when current will flow through this winding, flux or lines of magnetic force will be created in this path. So this will be the magnetic path. How to know the flux density? This is defined as flux passing per unit area. So B is equal to, I can write phi divided by area. Then magnetic intensity. So how much force we are experiencing in any field? So it can be defined as how much force we are facing or how much force is acting on a unit n pole. Why we have taken unit n pole? So we have to define its unit. We have taken suppose one point. If I will place it in a magnetic field, how much force is exerted on it? How much force is, or how much pressure you can say, or how much effect you can feel on that unit pole, that defined as intensity of the field. If the intensity is more, you will experience more force on this pole. If the intensity is less, you will face less force on this unit north pole. We have taken unit north pole. And what is the unit? Its unit is your unit is Newton per Weber. Okay, so Newton is the unit of force. How much force you are getting in that magnetic field? What is the unit of magnetic flux density? This is your Weber per meter square. Weber. And what is the unit of this? Weber. W-E-V-E-R. This is the unit of Weber. So flux is Weber. So you can see from this magnetic flux, we have defined these two terms. Magnetic flux means number of lines of force. Its unit is Weber. Per unit area, how much we are getting? That can be defined as Weber per meter square. How much force we are getting in a field? So Newton per Weber. How much force we are getting? You can see here magnetic intensity at any point in a magnetic field is defined as force acting on a unit north pole, or we can say one unit we have taken and we are observing how much force is exerted on it. So that's why the unit is Newton per Weber. Now the next important term is permeability. Permeability means how much lines of force are allowed by a particular element. Again, I am repeating, permeability means ability. This is your ability. Ability of a material to take the magnetic lines of force inside it. If any material is having greater permeability, its conducting power for magnetic lines of force will be more. So permeable means, if I will say one has more permeability, it is denoted as mu. It is denoted as mu. Okay. You can see here it is written magnetic core permeability denoted as mu. So mu, if mu is more, it is more means it will allow more magnetic flux inside it. Now suppose I will take an example of iron and let us take the example of wood. I hope all of you can see who is a magnetic material. Iron is a magnetic material. So definitely it means that more number of magnetic lines of force can flow through this iron. So permeability of which material will be higher? Definitely for iron it is higher. So more permeability means it is a good magnetic material. More permeability means it is a good magnetic material. Now let us find a relationship between B and H. Let us find a relationship between B and H. So B is lines of force per unit area. And what is the H? H is how much force we are getting in a magnetic field. So it is quite simple. If more number of lines of force are there, again I am repeating. What is B? B means number of lines of force in a particular area. So let me take two examples. Suppose this is one magnetic field. This is your magnetic field A and this is your magnetic field B. So all of you can observe more number of lines of forces here and less number of force are here, less number of lines are here. So B is definitely more here and B is less here. So definitely if I will place an unit north pole, force exerted on it will be more. That means H will be more here and H will be less here. So from this example, we can conclude that P is directly proportional to H. Now we need one proportionality constant. So it will be equal to mu H. And here mu is the, you can write what is mu? Mu is the permeability of the material. This is nothing but permeability of the material. And mu is equal to, we can write mu naught into mu r. What is mu naught? Mu naught is, you can write, this is the absolute permeability. Mu naught is, here I am writing, mu naught is equal to absolute permeability. And mu r is relative permeability of a material. That means when it is compared to a standard material, what is the standard here we are taking? Air. This is your relative permeability. And mu naught value is, please remember, very, very important, mu naught value is 4 pi into 10 to the power minus 7 H per meter. Okay. So no need to use this unit always. You can directly put this value 4 pi into 10 to the power minus 7. And mu r is the relative permeability. When the permeability is compared with air, how much permeability we are getting? That is your relative permeability. So from here, we are getting a important relationship. Note down this relationship, very, very important relationship. B is equal to mu naught into mu r into H. Now let us study one magnetic circuit, series magnetic circuit. How can I say this is a series magnetic circuit? So for an example of series electrical circuit, we are taking resistances in series. Here we are taking magnetic materials. See, this is one magnetic material whose length is L1. We can take its area as A1. Another magnetic material L2 whose area is A2. Area of cross section is A2. And another material L3 and another material air. So here 4 air gap. So how many materials here? 4 materials are connected. Just similar to our electrical circuit. When resistances are connected in series, what we do? What is the total resistance? R1 plus R2 plus R3. So here also we have to add all the opposition. Opposition means here the opposition is known as reluctance. Please note down reluctance. Acha, resistance is the opposition to whom? Resistance is the opposition to flow of current. Reluctance is the opposition to flow of flux. Okay, this is your flow of flux. So here you can see 3 different resistances are connected, or you can see 3 materials are connected, means 3 reluctances are connected. Now let us study. Let us study one basic rule here. Let us study one basic rule. That is Ohm's law of magnetic circuit. Ohm's law of magnetic circuit. Just a minute. Ohm's law of magnetic circuit. To understand that, we know in our electrical circuit, magnetic circuit, Ohm's law is B is equal to IR. B is equal to IR. V is your electromotive force, EMF. Similarly, here we will get magnetomotive force. This is your MMF. What is this MMF? MMF means the amount of work done required to carry a unit magnetic pole once through the entire magnetic field. In electrical circuit, what is the function of voltage? In electrical circuit, it is helping, or it is moving that electron in that circuit. Here also, the flux is moving in the circuit, and who is responsible for it? Magnetomotive force. So magnetomotive force will provide you the energy to move this flux, or to flow this flux in the circuit. Already we know what is the reluctance. V means here we will put in magnetomotive force is equal to current. In electrical circuit, current is flowing in the circuit. Here what is flowing in the circuit? Flux is flowing. And in case of R, resistance, we have understood reluctance is the opposition. So here we have to write S. So this is the formula for your Ohm's law. And reluctance means It is the opposition that a magnetic circuit offers to flux. So similar to your current, if you will analyze the electrical circuit, see the necessary voltage is given by, or the necessary force to flow that current in the circuit is given by this voltage source. This voltage source or electromotive force. Who is flowing? Current is flowing in the circuit. What is the opposition given to this current? Resistance. Similarly, here, who is giving the force to make this flux to flow through the circuit? MMF. MMF is used or giving the force or giving the power to move the flux throughout the circuit. And what is the opposition here? Reluctance. S. It's denoted as S. And this MMF. So MMF, from where we are getting this MMF? As we have already discussed, this current, when this current is flowing, through this winding, then this flux is produced. So if more number of flux or more number of current, we will get more number of flux. More current, more flux. And similarly, more number of turns means more flux. So this MMF can be written as, ampere turn. Ampere turn. Ampere turn. This MMF can be written as ampere turn. Its unit is written as ampere turn. So I hope all of you can understand this point, that when current is flowing through this winding, flux is produced. So current is directly proportional to flux. If number of turns is more number of flux or more flux will be produced throughout the circuit. So this MMF is nothing but number of turns multiplied by current. This current is also known as magnetizing current. Please note down this. This can be known as magnetizing current because this current is used to produce the flux. So what will be the force applied here? We can write number of turns into current. So its unit will be ampere turn. So what will be your Ohm's law? What will be your Ohm's law for your magnetic circuit? It will be MMF is equal to phi into S. MMF is equal to phi into S. We can write MMF is equal to phi into S. So we can derive, so you can see this is your series magnetic circuit as we have discussed. Before that, we can also derive the Ohm's law. We can also derive the Ohm's law. Here you can see we can derive the Ohm's law. Let us derive first Ohm's law, then we will go for the series circuit. So as you know, we will start the derivation from here. Already we know Ohm's law is equal to MMF is equal to your phi into S. Okay, so let us, very important, this is very important derivation, because from this derivation we will get number of equations to solve the numericals. So first let us write B is equal to phi by A. So magnetizing force, as you know, magnetizing force or intensity, H is equal to magnetizing force. Or intensity is equal to B by mu, we know, because H is equal to B is equal to mu H, we have already written. Okay. So B by mu means it can be written as B by mu naught into mu r. It can be written as flux divided by mu naught into mu r. This is one formula, or let me write, it is equation 1. But magnetizing force, what can be the definition? Magnetizing force. Magnetizing force. Magnetizing force means I can write it. How much MMF is there and which is distributed across the mean length of magnetic path. How we can get this definition? See, MMF means this is the force which is responsible to move this flux or to create this flux. It is quite natural. If the path will more or the path length will be bigger, whatever the MMF we are giving, we have to increase that MMF to make this flux to flow through the entire circuit. Again, I am repeating. Suppose this is one path. This is a small path. And this is a big path. If I am giving the same amount of MMF here also I am giving same MMF, here also we are giving same MMF. So here whatever MMF we are giving, it will be definitely more, as we have to flow the flux in a lower circuit or smaller circuit. Here the force will be less, because here we are making a bigger circuit. It is quite natural, because here force is same, but the length is different. Now here we will definitely get more force, as smaller amount of MMF is distributed in a small path. Here same amount of MMF distributed along a long path. So definitely we can know that magnetizing force is more here, less here. So from this example, we can conclude that magnetizing force means MMF divided by mean length of the magnetic path. So what will be the equation then? If this is MMF, so magnetizing force H is equal to, we can write Ni divided by mean length. Let me take L. This is your equation 2. So here we have got one equation, here we have got another equation. Now we can equate these two H. So what we will get? Phi divided by mu naught into mu r is nothing but equal to Ni divided by L. Or this can be written as phi is equal to Ni divided by, we can write like this, L divided by here I have forgot to written this flux per area, na? B is equal to flux per area. So A mu naught into mu r. Okay, and why I have written like this, why I have arranged like this, because this is a formula. This is the formula of reluctance. This is the formula of reluctance. So from here we can conclude a very, very important formula, that is Ni by S is equal to flux. Ni by S is equal to flux. This is our Ohm's law, because Ni is nothing but your MMF, which is equal to phi into S. Very, very important formula. Your flux is equal to MMF divided by reluctance. Please note down this formula, very, very important formula. Now we will go back to the series magnetic circuit. So for series magnetic circuit, you can see here multiple materials are there. This is one material, this is another material, this is another material. Air is also a material. So here, what should I write? Here, what we will write? Here, what I will write? Here, I will write total S is equal to S total. Means total reluctance is equal to S1, S1 for material 1 plus S2, just like your series circuit, plus S3 plus S4, or I can write this S4 as SG for air gap. And this can be written as L1 divided by A1 mu naught mu R1. This is for material 1. L2 is the length of the material 2. Area of cross section I am taking A2, which will be equal to mu R2 plus L3 divided by A2 plus mu naught mu R2 plus air gap. Let me write length of the air gap is Lg and area of the air gap is Ag mu naught. What is the mu R value for air? For air, mu R is equal to 1. So what? If I will write the total MMF is equal to total MMF is equal to flux. Flux is common because in series circuit we know current is same. Here same flux is flowing throughout the circuit, so flux is same divided into S total, which we can write like this, is equal to phi L1 A1 plus mu naught mu R1 plus phi into L2 A2 mu naught A2 mu naught mu R2. This is the relative permeability of material 2. Then flux into L3 divided by A3 mu naught mu R3 plus flux into Lg, length of the area, length of the air gap. Okay, length of the air gap. G for gap. Ag mu naught. Now you can see flux divided by area. Flux divided by area, I can write BL1 divided by mu naught mu R1. Here I can write, this can be written as B1, this can be written as B2, mu naught mu R2 plus B3, mu naught mu R3 plus B G for gap into mu naught into LG. Now see, B by mu, we know B is equal to mu H. If B is by mu, I am writing, I can write H. So which can be written as H1 L1 plus H2 L2 plus H3 L3 plus Hg Lg. So this is a very, very important relationship. We will solve or we will apply this concept for series magnetic circuit. We will solve some numerical on this series magnetic circuit. So very, very important. This particular formula, all these formulas are very, very important. So which relationship we will apply, it will depend which data are given in the problem or what is our task to find. Okay.